Hello, everyone. We're going to go ahead and get started on section 7.6, which is on student loans and home buying. So as an overview, does paying for college and paying for a home have in common? Well, they both cost a lot of money, and this means that you're going to need loans with probably longer terms than normal. So those are two common things that come about in a lot of people's lives. They're two very major purchases, especially a home, although you may not necessarily have to take out loans for college or anything like that, but a lot of the time loans are taken out for homes. But we're going to start off with student loans. So starting with student loans, the term can vary, but a standard term would be about 10 years with payments deferred until 6 months after your graduation. So typically a lot of loan borrowers see this, that they don't have to gain interest or they don't have to make payments for about 6 months after their graduation. And then they are expected to make payments after that if they are no longer in school. If you decide to go to grad school, your payments will be deferred another 6 months until after you are graduated with graduate school. So you do see those kind of differences occur with making payments on your student loans. We say student loans accrue simple interest, yay, not compound interest, while you are in school. So while you are in school, they gain interest, and that interest is simple interest. Once you are out of school and you are making payments, that is no longer the case. It does change. But while you're in school, interest accrued each month is constant, simple interest. The interest is calculated using a simplified daily interest formula. So simple interest we can use for specific types of like amounts of the year or how many years and things like that. But they do break it down into very much just day by day. So they break it down into how many days you were in school exactly to calculate that simple interest. So this is a little bit different than our simple interest formula. So we can simplify this by taking the annual interest, which is the principal balance times the interest rate, technically times 1 year, which would make that the simple interest formula. But it's your principal balance times the interest rate. And then you find the daily interest amount by taking that value and dividing by 365.25. This is one of the few times that we actually do divide by 365.25 when talking about a year. We take that annual interest and divide by that value. Then our monthly interest amount, we say we take our daily interest value and we multiply that by the days in the month. Since every month has a different number of days, this is how we get the most accurate representation as opposed to like, oh, just an entire year when maybe it was a couple days off or something like that. Or assuming a 30-day month when a lot of time there are a lot of 31-day months and then 28/29-day months as well. So we have much more accurate ways of calculating the simple interest, really broken down into like every single day that you are still in school. So I'm going to do an example. So when you borrow $6,500 in student loans at a 6.8% interest rate, we want to know what is her monthly rate for a 31-day month. Then we want to know how much interest will accrue while Sonia is still in school. Interest is going to be accruing for 4 years and 3 31-day months. So we're going to use the formulas on our last slide to find these values. So we're saying that she's borrowing $6,500 at a specific rate. So if we want to know what her monthly rate is, we'll need to find the annual interest, divide by 365.25 to find out how much it is each day. And then for one 31-day month, we'll need to multiply that value by 31. So to start off, we want to find the annual interest. Our annual interest will be the amount she borrows times the percent interest rate. So 6,500 times 0.068 in decimal. That value comes out to $442. So the annual interest is $442. Now we need to find the daily interest amount. So we're going to divide $442 by 365.25. And that'll give us $1.21 a day. So she's gaining an interest about $1.21 a day. So to calculate the monthly interest rate amount for a 31-day month, we're going to multiply our daily interest amount by the number of days in that month, which is 31. So we're going to multiply $1.21 times 31 to get $37.51. So we have that value there, $37.51 for a 31-day month. All right, then for part B, I want to know how much interest will accrue while Sonia is in school. We're saying that interest is accruing for 4 years and 3 31-day months. Now we know how much a monthly rate is for a 31-day month because we did that in part A. And then we're told 4 years. We're just going to go ahead and use the 4-year mark and use our simple interest formula for 4 years. So our annual interest for 4 years, we know our annual interest rate is $442, so we're going to multiply that by 4. That gives us $1,768. Then we'll go ahead and find the monthly interest for 3 31-day months. We already know the monthly interest amount for a 31-day month, so we'll multiply that by 3. So $37.51 times 3 would be $112.53. Then we can go ahead and add those values together by finding the interest accrued in school for 4 years and 3 31-day months. That end up being $1,768 plus $112.53 to give us $1,880.53. So now we can talk about the different types of student loans. So student loans can be taken out for undergraduate and graduate students, but there are 2 types of loans. One is much more beneficial as a borrower. There are differences. They're called subsidized and unsubsidized loans. A subsidized loan is only available to undergraduate students and it's based on financial need. So as a graduate student, you do not get subsidized loans. Your interest doesn't accrue until leaving school. Technically, the interest does accrue, but the government is paying that off while you are enrolled. So while you're still a student, your government pays off all of that interest that would have gained while you were in school. So by the time you graduate from school, you only have the principal to continue paying off, and then it will gain interest from then on. There are also lower loan limits for subsidized loans. So this would prevent you from taking out an extremely high value loan, like a $20,000 loan, that it will be harder to pay off. So these would be in lower loan limits to make them easier for you to pay off in the future. We put some stars around subsidized loans because these are the best loans to actually get if you do need student loans. If you have the option for subsidized or unsubsidized loans, subsidized loans are the ones you want to take out. Those are more beneficial to you. They will be more worth it in the long run. Because by the time you graduate, you'll only owe from the moment you graduate the amount that you actually borrowed. Interest would gain from there, as opposed to getting out of school and realizing, oh, I owe another $5,000 maybe, based on the loans that I took out because they were unsubsidized in that case. So moving on then to unsubsidized loans. They're available to undergraduate and graduate students. There's no financial need required. So you do not have to provide any sort of financial need to take an unsubsidized loan. Your interest accrues from time of the disbursement. So the moment you take out that loan, interest will accrue. The government does not pay for that interest. It is accruing, so that is meaning that when you graduate, your amount that you need to pay off will be higher than the amount that you actually borrowed. These also have higher loan limits. So these are also the $20,000, $30,000, $50,000 loans that they allow you to take out. They like you to have higher loan limits for unsubsidized loans because you start getting interest immediately. And they know that you can probably not pay that off while you're in school. So those would gain a lot of interest. So by the time you were out of school, you would owe substantially more than what you actually borrowed. And it would be that much harder to pay off in the future. So subsidized loans are better than unsubsidized loans for these reasons. So continuing on with student loans. When interest is not paid on student loans during college, aka unsubsidized loans, we say that the interest is capitalized. When interest is capitalized, it adds to the principal balance and results in larger payments. So every time interest is calculated, your new balance is going up and up and up. It doesn't use the original principal. When interest is not capitalized, payments must be made during college, but only covering the amount of interest. So your larger payments for capitalized interest, you wouldn't necessarily have to pay it while in school. But if it's not capitalized, you will have to make payments during school, but only for the interest amount. So by the time you graduate, you're still only paying what you originally bought or originally borrowed, but you made a lot of payments during school. And these only, once again, apply to unsubsidized loans. Only unsubsidized loans can have capitalized or not capitalized interest. Because remember, subsidized student loans gain interest, but the government pays it off, so it doesn't have anything to do with you. For capitalized interest, we say no interest is paid while the borrower is still in college, so you don't have to pay the interest while you're in school. Your principal balance, though, continues to grow larger while you are in school, and your payments are a lot larger when you graduate. So there's no pressure to pay off anything while you're in school. It's just gaining while you're in school. Not capitalized interest would mean that you do have to pay off the interest each month while you are in school. So you do have to make monthly payments on that value. The principal balance doesn't grow while you're still in school, though. So when you graduate, your principal will be the same as what you borrowed, except for the fact that you paid a lot while you were still in school. And your resulting payments after that will be smaller. So it's really up to you on what you decide to do. A lot of the time, I think capitalized versus not capitalized is an option that you can choose to do for whatever is available to you. Most of the time, with unsubsidized loans, the interest is typically capitalized, meaning that a lot of the time you don't pay anything while you're in school and you just get out of school with a much larger payment. So, all right, student loans, here's the formula. So the payments for a student loan can be computed with the following formula. For a 10-year student loan with principal P and interest rate R, written as a decimal, the monthly payment, capital R, is given by this formula. R is equal to P, principal, times R, the interest rate, divided by 12. All of that divided by 1 minus 1 plus your interest rate divided by 12, all to the power of negative 120. So this is the monthly payment on a student loan. Student loans typically use monthly payments. So that's why we use the net values of 12. Typically, the term is 10 years, but does not have to be. If your term isn't 10 years, your exponent is really just negative 12 times the number of years. So it's 120 because it's negative 12 times 10 for 10 years. So we see that this is our formula to calculate your monthly payments. So we're going to go ahead and try some out. So for our example, we're saying since Sonia borrowed $6,500 in unsubsidized student loans at a 6.8% interest rate, she now owes $8,380.53 at the same interest rate since she just graduated. So this is kind of a continuation of the problem that we had from earlier. What's Sonia's monthly payment if the loan term is 10 years? So first off, we need to start with the monthly payment formula. Our monthly payment formula, as we said, was R is equal to the principal times the rate divided by 12. All of that divided by 1 minus 1 plus the rate divided by 12, all to the power of negative 120. So we can go ahead and put in our information that we know of. Our principal, remember, is now $8,380.53. It's no longer the original principal. We say that it's an unsubsidized loan. We're going to assume capitalized. So now the principal is $8,380.53 at the same interest rate. So we put it in our formula. We have $8,380.53 times our interest rate in decimal, 0.068 over 12. All of that divided by 1 minus 1 plus 0.06 divided by 12, all to the power of negative 120. So we're going to need to calculate this value. Let's go ahead and use our calculator. All right, so when we calculate this, when we put this in our calculator, we need to be very careful about how we plug in these values. We do have a fraction, there's exponents. The exponents are only applying to certain things, so we need to be very organized with our parentheses. So since we do have a fraction, we always want to start with the top. So we'll have a set of parentheses to represent everything in the numerator, which will be $8,380.53 times. Now I have an additional fraction of 0.068 divided by 12. So I'm going to go ahead and put another set of parentheses around that. So I have 0.068 divided by 12. Finish off those parentheses and then finish off the parentheses for our numerator. So our numerator is finished. Now it's time to move on to the denominator. So we'll divide. And now we need another set of parentheses for the denominator. And I have 1 minus, and now I'm going to have a really big term that has an exponent. So I definitely need a set of parentheses for that whole term. Then I need a set of parentheses for what the exponent is actually going to. So now I can go ahead and type 1 plus, and I have another fraction. So another set of parentheses, 0.068 divided by 12. So parentheses to finish off that fractional part there. Then another set of parentheses to wrap up what the exponent is going to. Then we put in the exponent. We use the little caret button symbol here for our exponent. And that's the exponent of negative 120. It's important to notice that this symbol down here means negative. If you put minus, it will not work. Then lastly, that finishes off our denominator. So last parentheses there. So we'll go ahead and see what this equals. 96, looks like $96.44. So we'll go ahead and put that down in our lecture. So here's our answer, $96.44. And in this case, a month, because it's monthly payments. So that's how we use our monthly payment formula for our student loans. So we're going to do an example all together now. We're going to do, when Alex had 3 years left in college, she took out a student loan for $11,839. The loan had an annual interest rate of 4.29%, so annual interest in this case. Alex graduated 3 years after acquiring the loan and began repaying the loan immediately upon graduation. According to the terms of the loan, Alex will make monthly payments for 5 years after graduation, so not 10 years. During the 3 years that she was in school and not making payments, the loan accrued simple interest. So part A, if Alex's loan is subsidized, find the monthly payment. Now remember, subsidized means that the loan accrued interest, but the government paid it off. So if Alex's loan was subsidized, her monthly payment at the end of all of this will be based on her original principal. All the interest was already paid off. Then we have part B. If Alex's loan is unsubsidized, find the monthly payment. And in this case, once again, we're assuming capitalized interest. We're just going to assume that she owes a larger sum of money when she graduates. So with unsubsidized, we'll need to find how much interest accrued on that student loan during her 3 years, and then add that on to the original principal. That will give us the new principal for her unsubsidized loan. So that will be the difference. We're still using the same formula. A lot of the values will be the same, except for that value of P, the principal. So let's go ahead and go on over to our notes and work on this together. All right, so here's our question one more time. We know our monthly payment formula, which we have written down there. One important thing to note is that it is no longer to the power of negative 120. It's negative 12 times t. Where in this case, our loan, or our time for our loan is going to be 5 years. So t will be 5 in this case. So we have some values. We know t is equal to 5. We also know the interest rates. So little r in decimal, it's going to be 0.0429. So we know those two concrete values. So we're going to go ahead and get started with part A. When we start with part A, we know it's subsidized. So the principal will end up being the original. So principal will be $11,839. This is dollars. So that's going to be our principal. And all the interest that was accrued was paid off by the government. So now we can find our monthly payment. So we have our equation, R is equal to, and now we have our principal, 11,839, times the rate, 0.0429, divided by 12. All of that divided by 1 minus 1 plus 0.0429 over 12 to the power of negative 12 times 5, which is the value of t. So this is our equation. We're going to go ahead and use our calculator once again and find this value. All right, so we still have our last example up, so we're going to follow kind of our lead on what we did before with all of our parentheses, kind of have a little guide. So when we type this in, we're going to have our principal, which we said was $11,839 times, and now we have our interest rate divided by 12, so 0.0429 divided by 12. And there's 2 parentheses there, and then we're going to divide by 1 minus 2 parentheses, 1 plus another parenthesis, 0.0429 divided by 12. 2 more parentheses. We have our exponent. And we're now multiplying, so we're going to put an extra set of parentheses since it's now negative 12 times 5. End those parentheses. And one last one to finish off our denominator. Then we press enter, and we get our answer. So this looks like it's going to be about $219.59 a month in this case. We have 58, but then the next number is a 5, which really kicks the 8 up to a 9. So $219.59 is going to end up being our monthly payment for our subsidized loan. So let's go ahead and write that in our notes. So we had $219.59. This payment is once again a month. So that's for a subsidized loan. For part B, we need to move on to having an unsubsidized loan. So scroll down a little bit. So B, our new principal is going to be our principal with simple interest gained for 3 years. So if we remember, we said the amount of some sort of loan or investment, or our amount will be a certain formula, which takes in the principal and the interest rates and the time. So if we remember what we said for simple interest, the amount after a certain amount of time is principal times 1 plus the interest rate times time. That was the formula for finding our interest after a specific amount of time. So we're going to go ahead and plug our values in and solve this value. So our amount after, in this case, 3 years, is our principal, $11,839. times 1 plus the interest rate, 0.0429, times the time, which we said was 3. We're going to go ahead, put this in our calculators, find this value, which should come out to $13,362.68. So this value here is our new principal. So principal, which is new, will be $13,362.68. So this is the principal that we're going to use in our equation here. We're going to use the same equation to find our monthly payment. It's just that our principal is now much higher, about $2,000 higher. So go ahead and plug everything in. We have a formula R is equal to $13,362.68 times 0.0429 divided by 12, all divided by 1 minus 1 plus 0.0429 over 12 to the power of negative 12 times 5. So just like last time, we're going to go ahead, plug this into our calculator and see what we get. All right, so following what we did last time, it's going to look almost the exact same, the only difference being that the front values are different. So go ahead, type this in. We have $13,362.68. We're going to multiply that by 0.0429 divided by 12. There we go. In the numerator, all of that divided by 1 minus, and then we have 2 parentheses, 1 plus 0.0429 divided by 12. Then we have 2 parentheses to the exponent of negative 12 times 5. And that equals $247.85 a month. So that's our value. We've plugged into our calculator and calculated out. We see that with a principal that is higher, we're seeing probably about a 25, maybe a little bit closer to $30 increase in monthly payments. So it's not too terribly much more, but it is definitely enough to make an impact during an entire year, of course. So, all right, let's go ahead and write this answer in our notes. All right, we said this answer was $247.85 a month. So that would be the difference in having a subsidized versus unsubsidized loan and considering your monthly payments. Now, this loan was originally $11,000, turned into $13,000. Having an $11,000 loan could definitely be considered on the low end. Lots of people graduate with $50,000 or more. So we can only imagine that this situation times 5 can be very, very different. Having much higher loans to begin with makes much higher interest rates, which make for much higher payments. So these are always things to be aware of when taking out loans. Subsidized loans are always the best. Unsubsidized loans are definitely not so great. So, all right, that's how we calculate student loan payments for specific periods of time. So we'll go ahead and go back on to our lecture. All right, so we finished up this example. So moving on to home buying. The process of buying a home can be incredibly intimidating, but really great as well. Of course, you get a home out of it at the end. A mortgage is a long-term loan where the lender has the right to seize your property purchased if payments are not being made. Most mortgages are for about 30 years, but they are available anywhere between 15 and 50 years as well. And there are several types of mortgages themselves. You have fixed rate mortgages, meaning that your loan with an interest rate that remains the same over your entire term, meaning that when you sign that, agreement to your mortgages and whatnot, that interest rate is what you will have for the time of your mortgage. Then we have adjustable rate mortgages. These would be loans with an interest rate that fluctuates over the term. So maybe it changes during the type of your term, just depending on whatever was agreed upon to begin with. Then we have graduated payments. This is the ability to make smaller payments in the first few years of your loan and larger payments in the last few years of your loan, even though your interest is still fixed. So it basically just takes away some of the heat from the beginning when you probably just bought this home and you're probably a little bit younger and you may not have as much money, and kind of tax it on to the end when you're older and more financially stable, hopefully, and can probably make those payments better. So those are the types of mortgages, although typically we will be focusing on fixed rate mortgages. So loans with interest rates that will remain the same. But these are different types of mortgages, and there are different ones that exist out there. So finding the monthly payments or total interest. So monthly or just in general, periodic payments. So the monthly payment formula that we use for the student loans is actually like a very specific and special case of the formula that we use for home loans. Monthly payments are not necessarily always guaranteed for mortgages. You can have different amounts of time. It's typically monthly, but it's not always guaranteed. So we call these more like just periodic payments. We have a more general formula, although the general formula is technically the same as the student loan formula. So our periodic payments on a mortgage, we have our formula here, very similar looking to our student loan payment. We have R is the regular periodic payment, so as often as specified. P is the amount financed or the principal. R is the rate written as a decimal. N is the number of payments that you're making per year. And T is your number of years. So if it is truly monthly, then that value of N does become 12, and this does become the exact same as the student loan monthly payment formula. So they are the same formulas, but like we said, mortgages and payments are not necessarily always monthly when it comes to home buying. So let's go ahead and do an example using the formula. Our example is the Smiths bought a home for $489,000 with a 30-year mortgage and a rate of 5%. How much would their payments be if they paid bi-weekly, meaning every 2 weeks? So this is a unique case. Instead of having a very typical like monthly, weekly, now we have bi-weekly. That's going to be every 2 weeks. So basically all we need to do is take the number of weeks in a year, which is 52, and divide that number by 2. 52 divided by 2 is 26. So really we're talking about 26 weeks out of the year payments will be made. So 26 times a year. All right, so bringing up our periodic payment formula, which remember biweekly would be 26 times a year. We have R, our monthly payment, is equal to the principal times the interest rate divided by N, all over 1 minus 1 plus R over N to the power of negative NT. So same formula as before. Now we're going to plug everything in. So we have our principal, which is 489,000. Our interest rate of 5% is 0.05 divided by 26. 26 times a year. This is all divided by 1 minus 1 plus 0.05 divided by 26, all to the power of negative 26 times 30. 30-year mortgage, 26 times a year. So this is the formula that we're going to go ahead and use, but let's go ahead and put this all in our calculator to calculate the value. All right, so we're going to go ahead and plug our equation here into our calculator. We have our numerator here. We have $489,000 times our interest rate, 0.05, divided by the number of times we compound per year, or how many payments we're making per year, which is 26. That wraps up our numerator. We'll divide by 1 minus, then we have 1 plus 0, put some parentheses there, 0.05 divided by 26, have parentheses there and there, and the power of negative 26 times 30. And that wraps up our calculations. And that should end up giving us $1,210, about 98 cents. So that should be how much we end up paying for this bi-weekly mortgage that we have. So every 2 weeks, this is as much as we would owe. Although if I paid monthly, I would probably pay close to double that value because I'd be paying every 4 weeks instead of every 2 weeks. So there we have it. Let's go ahead and put our answer back into our lecture. All right, so here we go. We found that value. We said it was $1,210.98 bi-weekly. So every 2 weeks, this would be the amount that we would owe. So moving on, we have computing an amortization schedule. So this is used for things like mortgages to give us a schedule of payments. So after securing a mortgage, the lending institution will prepare an amortization schedule. Schedule shows what part of the monthly payment is actually paid on the principal and what part of your monthly payment is actually paid on the interest. Something we talked about at an earlier time was that when you start making payments on a loan in the beginning, your payments are mostly interest. At the end, your payments are mostly principal. So since you pay so much more interest in the beginning, your monthly payments are really going a lot more towards the interest. So you always want to make sure to subtract a down payment as well from the cost of your home before beginning an amortization schedule. If you put a down payment down, you definitely don't want to start making payments on an original amount if you paid a certain amount of it off. So always do remember to pay off those down payments first. So the procedure for computing an amortization schedule is in about 3 steps, but technically step 3 has 2 parts. So in step 1, you find the interest for the first month. You use the simple interest formula, interest equals principal times rate times time, but your time is now 1/12 because it's monthly and 1/12 would be 1 month, 1/12 of the year. Then you're going to enter this value in a column labeled interest. Step 2, you would subtract the interest from the monthly payment in order to get the amount paid on the principal. You are going to write this amount in a column labeled payment on principal. Step 3, part 1, you'll subtract the amount of the payment on principal found from step 2 from the principal amount to get the balance of the loan. You'll enter this in a column labeled balance of loan. Then your last part here is repeat the steps using the amount of the balance found from step 3 for the new principal. So as you do more lines, more rows of your amortization schedule, you have to remember your new principal is really whatever the balance was left over from the previous row. It's always good to remember that. So as our final example, we're going to go ahead and build an amortization schedule. Our example here is that the Petty's family plans to buy a home for $174,900, clearly in the middle of nowhere, and has been offered a 30-year mortgage with a rate of 4.5% if they make a 20% down payment. Their monthly payment is going to be $708.95. We're going to compute the first 2 months of an amortization schedule for this loan. So for this example, we already know our monthly payment. We know that we have to make a 20% down payment. So we need to pay that off first, figure out how much that is. And then we'll start computing our amortization schedule. So, all right, let's go ahead and go on over to our notes to work on this one. All right, so here's our example. We do have our amortization schedule already here at the bottom, so we'll just fill in information as we get it. But to start this problem off, we said that they would make a 20% down payment, so we need to factor that out of our value. don't want to use the principal of 1,700, 1,000, sorry, $174,000, there we go, $900, especially if we're making that down payment. So you need to figure out how much is the down payment. So down payment, we know is going to be 20% of the original value. So 20% in decimal is 0.2 times our original principal, 174,900. So we'll go ahead and calculate this value to find out how much the down payment's going to be, which is $34,980. So using our down payment, we're going to take this value off of our original principal to get our new principal. So our new principal is 174,900 minus 34,980, which should give us the value of $139,920. All right, so we have the value of our principal. We know principal in this case is 139,920. We have our interest rate, we said was 4.5%, so really 0.045. And then we said time is always going to be 1/12 to represent 1 month. So we can go ahead and get started. We said step 1, this is going to be part 1. Step 1, we said it was to find the interest for 1 month using our interest formula, which was interest is equal to principal times rate times time. Our principal is 139,920 times the rate, 0.045, times the time, 1/12. So we're going to go ahead, plug this in our calculator, round to the nearest 2 decimal places for cents to get that our interest should be $524.70. All right, so this is the first value that we can write in our amortization schedule. So we're going to scroll down. So for payment number 1 in interest, we're going to put $524.70. So that goes in the first box. Now step 2 is to find the payment on principal, meaning we're going to take the monthly payment, which is R, and we will subtract the interest from that value. That was one thing we forgot to kind of label from the beginning, but we can do that now. So we can go ahead and fill that in up here in the beginning. We said capital R, the monthly payment, is $708.95. So for step 2, we're going to subtract the value of our interest from the amount that we pay per month. That's going to actually go towards the principal in this case. So step 2, we take monthly payment, R, and subtract the interest from the previous step. So this comes out to $708.95 minus $524.70. So we subtract those values, we use a calculator, and we should get $184.25. So that's the value. So we'll go ahead and put our $184.25 in our payment on principal box. That's next. So that's how much we're actually going to pay off of the principal. So for step 3, what we do is subtract the payment on the principal from the actual value of the principal. So principal minus payment on principal. So our principal was $139,920 minus $184.25. Plugging this into our calculator, it's going to give us $139,735.75. And this is the value that goes into our balance of loan for our first payment. So this is $139,735.75. And that's the first row of our amortization schedule. So now we want to do the second. We're going to repeat all of our steps. It's just that our new principal is going to be the balance of loan from the first payment row. So for part 2 of our amortization schedule, we'll do the same steps once again. So step 1 is still our interest formula, but remember our principal is now different. Our principal is the previous balance of loan, which we said was $139,735.75 times our interest rate, which is still 0.045, times time, which is still 1/12. We'll round this value off to 2 decimal places. Go ahead, plug this into our calculator. You get $524.01 in this case. And that goes in the interest box for payment number 2. So $524.01. So now we have step 2. So for step 2, same thing as before, monthly payment minus the new interest that we have here. So our monthly payment is still $708.95. That's not going to change, minus our new interest, $524.01. So calculating this value out, go ahead and we get $184.94. So now this is our payment on principal, which goes in the second box for payment 2. So now our payment on our principal is $184.94. And lastly, step 3. Step 3, we take our principal, which remember was our previous balance of loan, minus our new payment on principal. So this will be $139,735.75 minus $184.94, which leaves us with our new balance of loan, $139,550.81. So we'll fill that in our very last box here. $139,550.81. So we filled in the 2 first lines of our amortization schedule. So we see that as the months go on, we'll start seeing that the interest value will start getting lower. The payment on our principal will start getting higher, and therefore our balance of loan will start decreasing as well, eventually until it becomes 0. So that's how we compute an amortization schedule when it comes to having mortgages. So, all right, let's go ahead and go back on over to our lecture. All right, so that was that example. And that wraps up section 7.6. So in 7.6, we learned how to compute the interest on a student loan, how to compute payments on a student loan, how to find a monthly mortgage payment, how to find the total interest on a home loan, compare two mortgages with different lengths, and make an amortization schedule for a home loan. So, all right, that wraps up section 7.6, and I'll see you in the next one.